Yes. Inverse trigonometric functions. Inverse trigonometric functions based on the concept. We have discussed some problems here. First one. What is the range of sine inverse x? Already we know that the domain of sine inverse x is -1 to +1. Closed interval -1 to +1. We want range of sine inverse x is clearly closed interval -π/2 comma. Range of sine inverse x is closed interval -π/2 comma π/2. Domain of the sine inverse x clearly closed interval -1 comma +1. So, and second one, observe. What is the domain of secant inverse x? We want domain of secant inverse x. Already we know that the domain of secant inverse x is equal to clearly -infinity to -1 union 1 to infinity. Left open, right closed, -infinity to -1 union, left closed, right open, that is 1 to infinity. This is the domain of secant inverse x. What is the range? Range of secant inverse x is closed interval 0, π minus π/2. Closed interval 0, π minus π/2, not at all π/2. So the domain of the secant, here we want domain of the secant inverse x is left closed, left open, right closed, -infinity to -1 union, left closed, right open, 1 to infinity. Left open, right closed, left closed, right open. That means -1 is included. Here 1 is included. So the domain of sine inverse x plus cos inverse x we want. The domain of sine inverse x plus cos inverse x. Already we know that the domain of sine inverse x is clearly closed interval -1 comma +1. Domain. Also, domain of the function cos inverse x also closed interval -1 to +1. We want the domain of the sine inverse x plus cos inverse x. Sine inverse x plus cos inverse x. What is the intersection got here? Therefore, domain of sine inverse x plus cos inverse x. Sine inverse x plus cos inverse x. Intersection point is clearly -1 to +1. So domain is clearly -1 to +1. The domain of sine inverse log x²/2 to the base 2 is. We want the domain. Clearly we know that what is the domain of sine inverse? Consider this is x. What is the domain of sine inverse of x? Clearly -1 is less than or equal to. Consider this is t. So sine inverse of t, the domain of sine inverse of t is clearly closed interval -1 to +1. So -1 is less than or equal to log x²/2 to the base 2 is less than or equal to 1. So clearly the domain of sine inverse of x, sine inverse of t, consider this is log x²/2 to the base 2 is considered t. So sine inverse of t is clearly domain is -1 to +1. So consider t means here log x²/2 to the base 2. Log x, we know that a power x is equals to n. This is exponential form. Logarithmic form is log n to the base e. This is exponential form. This is logarithmic form. We want logarithmic. This is logarithmic form. Exponential form is clearly 2 power -1 is less than or equal to x²/2 is less than or equal to 2 power 1. Log x equals log n to the base a power x equals to n. A power x is equals to n. So both sides totally multiply by 2. We get here 2 power -1 is nothing but 1/2 into 2 is less than or equal to x² is less than or equal to 2 to 4. So 2 and 2 get cancelled. We get 1 is less than or equal to x² is less than or equal to 4. That means 1 is less than or equal to x² or x² is less than or equal to 4. So x² is greater than or equal to 1. X is greater than or equal to plus or minus 1. That means x is greater than or equal to 1 or x is less than or equal to minus 1. X is less than or equal to minus 1. That means x is belongs to -infinity to -1 union 1 to infinity. -1, x value -1 less than minus 1. That means we get minus infinity to minus 1. X is 1 to infinity. 1 to infinity. We get 1 to infinity. And also x square is less than or equals to 4. X square is less than or equals to 4 means x value clearly lie between minus 2 is less than or equals to x is less than or equals to 2. X value lie between minus 2 is less than or equals to x is less than or equals to 2. Minus 2 is less than or equals to x is less than or equals to 2. This is. Here, roots is minus infinity to minus 1 union 1 to infinity. Here, roots is minus 2 is less than or equals to x is less than or equals to 2. What is the intersection point here? Clearly, the domain of this one is the domain of sine inverse log x square by 2 to the base 2. Log x square by sine inverse of log x square by 2 to the base 2 is clearly what is the intersection point? Here x is lying between minus 2 and plus 2. Here x is minus infinity to minus 1 union 1 to infinity. Intersection point is clearly x domain is minus closed interval minus 2 to minus 1 closed interval union 1 to 2. What is that? X is here, x square is less than 4. This is x is lying between minus 2 to plus 2. Here x is this is. Intersection point is clearly minus 2, closed interval minus 2, minus 1 union 1 to 2. This is. Next, what is the domain of log sine inverse x to the base e is? How do we know that? Domain of sine inverse x is equal to clearly minus 1 to plus 1. Domain of sine inverse x is equal to clearly minus 1 to plus 1. But here, logarithmic function is that log sine inverse of log function means sine inverse x are here, logarithm is there, so sine inverse x is always greater than 0. Always. Why? Because logarithmic functions does not exist for negative numbers. So sine inverse x values are always greater than 0. So the domain of log sine inverse x to the base e is clearly greater than this. Sine inverse x is greater than 0. That means we get 0 to domain is 0 to 1. This is the open interval, that is left open 0 to 1, right closed. This is. Next, in the interval, closed interval minus 1 to plus 1. What is the tan inverse of x? Tan inverse of x. Clearly, minus 1 to plus 1, the tan inverse of x is increasing function. Increasing function. Why? Because if you observe the graph of the tan inverse of x, this is 5 by 2. Already we know that. This is minus 5 by 2. What is the graph of the tan inverse of x? This is the graph of the tan inverse of x. So interval minus 1 to plus 1. Interval, if you take this is minus 1, this is plus 1. Interval minus 1 to plus 1, clearly the function is the tan inverse of x is clearly increasing function. Interval minus 1 to plus 1, the function is clearly tan inverse of x function is clearly increasing function. In the interval minus infinity to minus 1, what is the secant inverse of x? Secant inverse of x also solution. Secant inverse of x also here also increasing function. Increasing function. If you observe the graph of secant inverse x, clearly this is. If you observe the graph secant inverse x, minus infinity to minus 1 is secant inverse x graph is increasing function. So that's right. In the interval minus infinity to plus infinity, what is the cot inverse x? If you cot inverse x graph is clearly decreasing function. decreasing function in that interval. Minus infinity to plus infinity, cot inverse x is clearly decreasing function. If you observe the graph of cot inverse x, this is minus or plus of x, this is or minus of x. The graph minus infinity to plus infinity, the graph is clearly decreasing function. Minus infinity to up to plus infinity, the graph of tan inverse x is clearly decreasing function. This is next one. The value of tan inverse 3 by 4 plus tan inverse 1 by 7 is. Already we know that clearly tan inverse x plus tan inverse y is equal to tan inverse x plus tan inverse y is equal to tan inverse of x plus y by 1 minus x. Already we discussed in properties. That is tan inverse x plus tan inverse y. Clearly x is greater than 0, y also greater than 0. X is greater than 0, y also greater than 0. X into y. If you do means x into y is less than 1. X is clearly here, observe here, x is greater than 0, positive, so x is greater than 0. Y also here greater than 0, x is greater than 0, y is greater than 0. If you do x into y means 3 by 4 into 1 by 7, that is 3 by 28. Clearly, 3 by 28 is clearly less than 1. So x into y is less than 1. What is the tan inverse x plus tan inverse y? Tan inverse x plus tan inverse y. If x is greater than 0, y is greater than 0. If xy is less than 1. If xy is less than 1, then tan inverse of x plus tan inverse y equals tan inverse of x plus y by 1 minus x. So tan inverse of 3 by 4 plus tan inverse of 1 by 7 is equal to tan inverse of x value here clearly 3 by 4 plus y value 1 by 7 by 1 minus 3 by 4 into 1 by 7. That is equal to tan inverse of here clearly 7 fours 28 is LCM. 7 threes are 21 plus 4 ones are 4 by 7 fours 28 minus 3 by 7 4 28 minus 3 by clearly 28 is that is equals 28 and 28 get cancelled. We get tan inverse of 21 plus 4 clearly 25 28 minus 3 25. We get 25 by 25. That is equals to tan inverse of we get 1. Tan inverse of 1. We know that tan pi by 4 value, tan pi by 4, that is tan 45 value 1. So 1 can be written as tan inverse of tan pi by 4. Tan inverse of tan theta clearly also we get pi by 4. So pi by 4 is the answer. Pi by 4 is the answer. Pi by 4. This is. So x is greater than 0, y is greater than 0, x into y is less than 1. What is the value of tan inverse of x plus tan inverse of y is equal to tan inverse of x plus y by 1 minus x. X plus y by 1 minus x. This is. Next one, solution. Clearly. If sin inverse of x plus 4 cos inverse of x is equal to pi, then x is equal to how much? Sin inverse of x plus 4 times of cos inverse of x. Cos inverse of x can be written as pi by 2 minus sin inverse of x. Pi by 2 minus sin inverse of x clearly. Cos inverse x can be written as pi by 2 minus sin inverse x. Cos inverse x equals to pi by 2 minus sin inverse x. That means sin inverse x plus cos inverse x. Where do we know that? Sin inverse x plus cos inverse x is equal to how much? Pi by 2. Already we have property. That is sin inverse x plus cos inverse x equals to pi by 2. We want cos inverse x. Cos inverse x is equal to, if you transpose means we get pi by 2 minus sin inverse x, we get pi by 2 minus sin inverse x. So cos inverse x equals to pi by 2 minus sin inverse x. Right here, cos inverse x is pi by 2 minus sin inverse x. Is equal to, already they give pi, the value is pi. So if you multiply here, we get sin inverse x plus 4 into pi by 2, that is 2 pi minus 4 sin inverse x is equal to pi. 4 into pi by 2, 2 2s are get cancelled, 2 pi minus 4 sin inverse x is equal to how much? Pi. Sin inverse x minus 4 sin inverse x, we get minus 3 sin inverse x plus 2 pi is equal to to pi. Or transpose here, minus 3 sin inverse x is equals to pi minus 2 pi. So minus 3 sin inverse x is equals to pi minus 2 pi, we get minus 5. So minus and minus get cancelled here. Sin inverse x is equals to pi by 2. Sin inverse x, if you transpose 3 here, we get sin inverse x equals to pi by 2. What is if sin inverse x is equals to alpha, x is equals to sin alpha. So if you apply both sides sin function, we get sin of sin inverse x, we get x is equals to sin pi by 2, sin pi by 2. Sin of sin inverse, apply both sides sin function, sin into sin inverse x, sin into sin inverse x, sin pi by 2. That is x is equals to sin pi by 2 is 180 by 3, we get 60. So we get sin pi by 3 is square root of 3 by 2. Square root of 3. Sin pi by 3. 180 by 3. Sin 60 by root 3 by 2. Sin 60 by root 3. So what is the x? X here clearly square root of 3 by 2 is the next one. The value of cos of 2 cos inverse x plus sin inverse x at x is equals to 1 by 5 is at x equals to 1 by 5. Solution. This can be written as cos of 2 cos inverse x means we get cos inverse x plus sin inverse x. Cos of 2 cos inverse x can be written as cos inverse x plus cos inverse x. So cos inverse x plus sin inverse x value. Cos inverse x was already we know. That is sin inverse x plus cos inverse x value. How much means? Clearly pi by 2. Sin inverse x plus cos inverse x value. How much? Pi by 2. So this can be written as pi by 2. Pi by 2 plus we get again 1 cos inverse x plus this cos inverse x. So sin inverse x plus cos inverse x value. How much? Pi by 2. We get cos inverse x. Pi by 2 plus cos inverse x. Pi by 2 means already 90. Sin 90 plus theta. Sin 90 plus theta lies in second quadrant. In the second quadrant, cos have negative signs. So we get minus sin of cos inverse x. Since cos 90 plus theta clearly minus sin. Cos 90 plus theta is equal to minus sin. Cos 90 plus theta minus sin. This is considered. So minus sin times of cos inverse of x. Minus sin times of cos inverse x. Cos inverse x is equals to, already we know the properties. Cos inverse x is equals to sin inverse of square root of 1 minus x square. Cos inverse x is equals to sin inverse of square root of 1 minus x square. So cos inverse x can be written as sin inverse of square root of 1 minus x square. So sin of sin inverse theta, sin of sin inverse x, we get x only. So we get minus square root of 1 minus x square. But at x is equals to 1 by 5, at x is equals to 1 by 5, we get minus square root of 1 minus 1 by 5 whole square. That is equals to minus square root of 1 minus 1 by 25. That is equals to square root of minus times of square root of 25 minus 1. 25 minus 1 clearly 24 by 25. 24 by 25. That is equals to minus times of. This can be 24 can be written as 4 into 6 by 25. 25 can be written as square root of 25. So 4 into 6. 4 into 6 means minus root 4 means we get to root 6 by 25 means 5. So minus 2 times of 2 root 6 by 5. Answer is minus 2 root 6 by 5. Next. Observe here. Solution. Sigma means clearly summation. K value up to n. So this can be written as sin inverse of. If you substitute here, we get sin inverse x1 plus. Sin inverse to substitute x equals to x2 plus. Sin inverse x3 plus and so on plus sin inverse xn is equals to clearly n by n pi by 2 up to n times n by 2. So sin inverse x1 plus sin inverse x2 plus sin inverse x3 plus and so on sin inverse xn is equal to n by 2. Already we know that the range of sin inverse x range of range of sin inverse x equals clearly, range of sin inverse x equals clearly minus pi by 2 comma pi by 2. This is the range of sin inverse x. So if you take maximum pi by 2, here minimum minus pi by 2 is maximum plus pi by 2. If you take maximum plus pi by 2, we get pi by 2 plus pi by 2 plus pi by 2 plus up to n times, we get n pi by 2. Here answer is n pi by 2. So if you take a maximum value is pi by 2, this is also pi by 2, pi by 2, pi by 2, pi by 2 up to we get n times, so that's why we get n pi by 2. That means this is sin inverse x1 is nothing but, if you take sin inverse x value pi by 2, pi by 2, pi by 2, pi by 2, that means we get n pi by 2. That means each value, that is sin inverse x1 value is equals to sin inverse x2 value is equals to sin inverse x3 value is equals to, and so on, is equals to sin inverse xn is equals to value pi by 2. Up to n terms, pi by 2 plus pi by 2 plus pi by 2 plus pi by 2, up to n terms, we get n pi by 2. So here sin x1 inverse, sin inverse x1 value, sin inverse of x2 value, sin inverse of x3 value, all values same. So pi by 2 plus pi by 2 plus pi by 2 become equal to pi by 2. Then only we get n pi by 2. If you take maximum value pi by 2, then we get n pi by 2. So sin inverse of x1 equals to pi by 2. What is the value of x1? x1 equals to, x1 is equals to how much? x1 is equals to sin inverse of x1 equals to pi by 2. x1 is equals to sin pi by 2. Sin pi by 2. Sin pi by 2 is sin 90. Sin 90 value how much? 1. So we get x1 is equals to 1. x1 1. So x1 is equals to x2 is equals to x3 value. Or up to xn value also equals to 1. Sin inverse x1 value pi by 2. Sin inverse of x equals to pi by 2. X equals to sin pi by 2. Sin pi by 2 value how much? Sin 90 value 1. So x1 equals 1, x2 equals 1, x3 equals 1, x3 up to xn equals to 1. So this value is how much? 1. So we want sigma k is equals 1 to n x k we want up to n terms. That means x1 plus x1 plus x2 plus x3 plus and so on up to xn is equals plus xn. So 1 plus 1 plus 1 plus and so on plus 1 plus 1 n times. So 1 plus 1 plus 1 plus 1 plus 1 up to n times, that is we get n into 1, so we get n. That is the answer. N is the answer. 1 plus 1 plus 1 plus 1 plus up to n times, so we get n. Answer is n. What is the range of sin inverse x plus cos inverse x plus tan inverse x value we want? So first of all, what is the domain here? The domain of sin inverse x is clearly minus 1 to plus 1. Cos inverse x also close into minus 1 to plus 1. Already we know that. The domain of sin inverse x is minus 1 to plus 1. Cos inverse x domain is also minus 1 to plus 1. What is the tan inverse x domain? Tan inverse x domain is clearly all the real numbers. All the real numbers. So the domain of sin inverse x plus cos inverse x plus tan inverse x is equals to clearly close into minus 1 comma plus 1. We want range. Already we know that sin inverse x plus cos inverse x value. Sin inverse x plus cos inverse x value. So sin inverse x plus cos inverse x value pi by 2. Pi by 2 plus tan inverse x. Pi by 2 plus tan inverse x. Sin inverse x plus cos inverse x value we have pi by 2. Already we have it. That is what? Property. Sin inverse x plus inverse trigonometric property. That is sin inverse x plus cos inverse x value pi by 2 plus tan inverse x. So we want the range of this function. So x belongs to minus 1 to plus 1. Tan inverse x belongs to minus 1 to plus 1. What is the range of tan inverse x means? X belongs to minus 1 to plus 1. For x is tan inverse of x is clearly tan inverse of x is lies between minus pi by 4 plus pi by 4. Tan pi by 4 value minus 1. Minus pi by 1, this is plus 1. So tan inverse x value lies between minus pi by 4 comma plus pi by 4. We want the domain of range of this function pi by 2 plus tan inverse x. So here we want pi by 2. Both sides add pi by 2. We get pi by 2 minus pi by 4 is less than or equal to pi by 2 plus tan inverse x is less than or equal to pi by 2 plus pi by 4. Pi by 2 minus pi by 4. Pi by 2 minus pi by 4. Here 4 is LCM. 2 pi minus pi. 2 pi minus pi is less than or equal to pi by 2 plus tan inverse x is less than or equal to. Here also 4 is LCM. 2 pi plus pi. 2 pi plus pi. So 2 pi minus pi. 2 pi minus pi will be pi by 4. Pi by 4 is less than or equal to pi by 2 plus tan inverse of x is less than or equal to 2 pi plus pi 3 pi by 4. So range is equal to range of function is equal to clearly close and we get pi by 4 comma 3 pi by 4. This is the range of the function. Range of the given function. This is next the value of x where x is greater than 0. Where x is greater than 0, find the value of tan of secant inverse x. Here, solution is given. Let secant inverse 1 by x is equal to alpha, comma, tan inverse 2 is equal to some beta. Secant inverse 1 by x is equal to alpha, tan inverse 2 is equal to beta. Clearly, 1 by x is equal to secant alpha, 2 is equal to tan beta. 1 by x is equal to secant alpha, 2 is equal to tan beta. So, secant alpha is equal to 1 by x, tan beta is equal to 2 e. So, we want here secant alpha means take right angle triangle. Here, right angle triangle. This is. Here also take right angle triangle. This is. So, here take alpha. Secant alpha means clearly secant means how much? Hypotenuse by adjacent side. Adjacent side of alpha. Tan beta means here beta. This is right angle. Tan means here half that means 1 is here 2 by 1. So tan means opposite side to theta by adjacent side to theta. This is. So what is the value of x by using of Pythagoras theorem? By Pythagoras theorem, this we have that is clearly 1 minus x. 1 minus x. Here also by Pythagoras theorem, 4 minus 1 we get root 3. This is. So we want secant, we want tan. What is the value of tan alpha? Tan alpha is equal to opposite by adjacent. Square root of 1 minus x square by x tan alpha. Here also we want in terms of sin beta is equal to opposite by hypotenuse 2 by root 3 2 by 2. So alpha is equal to tan inverse of square root of 1 minus x square by x. Here also beta is equal to sin inverse of 2 by square root of sin inverse of 2 by square root. Apply here tan alpha plus that is tan alpha is equal to sin beta we get. That is alpha, this is beta. So tan alpha means we get here tan inverse of square root of 1 minus x square by x is equal to sin inverse 2 by square root 3. Tan inverse x clearly x. So we get here by using of this property 1 minus x square by x is equal to sin inverse x. We get x only, so we get 2 by square root. We want x value, so squaring on both sides, we get here 1 minus x square by x square is equal to 4 by. If you do squaring on both sides, we get this. If you do cross multiplication, 3 ones are 3 x square minus 3x square is equal to 4x. 3 ones 3 x square 3x is equal to 4x. If you transpose, 3 is equal to 4x square plus 3x square. So 4x square plus 3x square clearly 7x square is equals to 3. X square is equals to 3 by 7. If you transpose 7 here, we get 3 by 7. X is equals to plus or minus square root of 3 by 7. So what is the value of x? X is clearly plus or minus square root of 3 by 7. X equals to, so here where x is greater than 0, so x is equals to, we get x is equals to square root of 3 by 7 is the answer. X is greater than 0, so that's why x value clearly, that is square root of 3 by 7. Square root of 3 by 7 is. Next one, cos of sin inverse 2 cos square theta minus 1 plus cos inverse 1 minus 2 sin square theta value we want. So clearly, observe here, cos 2 theta formulas already we discussed in previous. Cos 2 theta is equals to 2 cos square theta minus 1 or 1 minus 2 sin square theta. 1 minus 2 sin square theta. These are the cos 2 theta formulas. Or cos square theta minus sin square theta. Cos square theta minus sin square theta. Or 1 minus tan square theta by 1 plus tan square theta are the formula for cos 2 theta. So cos 2 theta is equals to 2 cos square theta minus 1, 1 minus 2 sin square theta. So this can be written as cos of sin inverse 2 cos square theta minus 1. 2 cos square theta minus 1 is nothing but cos 2 theta. Plus cos inverse of 1 minus 2 sin square theta. 1 minus 2 sin square theta is nothing but cos 2. Cos 2. This is. Consider this is x. Cos 2 theta is nothing but x. This is also x. Already we know that. Sin inverse x plus cos inverse y. Sorry, sin inverse x plus cos inverse x. Sin inverse x plus cos inverse x. Let us cos 2 theta equals x. So sin inverse x plus cos inverse x is equals to how much? Pi by 2. This is clearly pi by 2. So sin inverse cos 2 theta plus cos inverse of cos 2 theta also how much? Pi by 2. So we get cos. This value is sin inverse x plus cos inverse x value pi by 2. This is pi. Cos pi by 2, cos 90 value, cos 90, clearly cos 90, 0. So we get 0. Cos pi by 2 is nothing but 0. Next, sixth one. If sin inverse x plus sin inverse y plus sin inverse z is equals to 3 pi by 2. Already we know that sin inverse x, clearly range is sin inverse x range of the function is clearly minus pi by 2 plus pi by 2. This is the range of the sin inverse of function. So sin inverse function, sin inverse x is equals range is minus pi by 2 plus pi. So they give sin inverse x plus sin inverse y plus sin inverse z value 3 pi by 2. Sin inverse theta, sin inverse x value range is minus pi by 2 plus pi by 2. So minimum is minus pi by 2, maximum is plus pi by 2. So when we get 3 pi by 2 means if sin inverse x is maximum, we get pi by 2 plus pi by 2 plus pi by 2 is nothing but 3 pi by 2. Pi by 2 plus pi by 2 plus pi by 2 is nothing but 3 pi by 2. So here sin inverse x value, sin inverse y value, sin inverse x value is equal to sin inverse y value is equal to sin inverse z value is equal to pi by 2. Then only we get pi by 2 plus pi by 2 plus pi by 2, we get 3 pi by 2. So sin inverse x is equal to pi by 2. X is equal sin inverse of x is equal to sin inverse of x is equal to pi by 2. That means x is equal to how much? Sin pi by 2. That is equal to. So x is equal to clearly x is equal to y is equal to z is equal to how much? Sin inverse of y is equal to pi by 2. So y is equal to 1. Sin inverse of z is equal to pi by 2. Z is equal to 1. So x equals y is equal to z is equal to 1. That means x value, y value, z value how much? 1. So we want this is x power 100, x power 100 plus y power 100 plus z power 100 minus 9 by x power 100 plus y power 100 plus z power 100 value we want. X power 100, that means 1 plus, that is 1 power 100. 1 power anything is 1 only, so 1 plus, here also we get 1 plus, here also 1 minus 9 by 1 plus 1 we get 1 power 100, nothing but 1. 1 power 100, nothing but 1 power 100. So that is equal to 3 minus 1 plus 1 plus 1, 3 3 minus 9 by 1 plus 1 plus 3. 3 ones are 3 threes are. That is equals to 3 minus 3. We get 0. 0 is the answer. 0 is the answer. Observe here, sin inverse x, the range is minus pi by 2. Closed interval minus pi by 2 plus pi by 2. Minimum value is minus pi by 2. Is maximum is pi plus pi by 2. If you take maximum, we get 3 pi by 2. So sin inverse x, sin inverse y, sin inverse z equals to pi by 2. So what is the value of x? X value, y value, z value is nothing but 1. So then only we get this is 0. So substitute here, we get 0 is the answer. Yes, next problem, observe here. This is, if x is greater than 1 by root 3, if x is greater than 1 by root 3, if x is greater than 1 by root 3, then tan inverse of 3x minus x cubed by 1 minus 3x square equals to. Already we have formulas, that is properties of inverse trigonometric functions in concept. Already we learned about these formulas, that is already we discussed in previous. That is 3 tan inverse x is equals to, if x is greater than 1 by square root of 3, if x is greater than 1 by square root of 3, then we have a formula that is 3 tan inverse x is equals to, 3 tan inverse x is equals to pi plus tan inverse of 3x minus x cubed by 1 minus 3x square. We have a formula in previous, that is properties of inverse trigonometric functions. Already we discussed in previous, that is x is greater than 1 by root 3, then 3 tan inverse x value, 3 tan inverse x value, pi plus tan inverse of 3x minus x is cubed by 1 minus 3x square. We want this value. If you transpose pi here, we get tan inverse of 3x minus x cubed by 1 minus 3x square is equals, if you transpose plus pi from RHS to LHS, it will becomes minus pi. So we get here 3 tan inverse x minus pi is the answer. 3 tan inverse x minus pi is the answer. Next, we want the domain of this function secant inverse x plus tan inverse x domain we know. Already we know that the domain of secant inverse x is equals to, that is minus infinity to minus 1 union 1 to infinity. That is domain of secant inverse. Domain of the function is tan inverse x is equals to, tan inverse x is equals to, already we know that all the real numbers. We want domain of secant inverse x plus tan inverse x means we want the intersection point of this and this, all the real numbers in this one. What is the intersection point? Means clearly we get minus infinity minus 1 union 1 to infinity is the domain of the this one. So intersection point, common point is minus 1 to minus infinity to minus 1 closed interval, union 1 to infinity is the intersection point of these two functions. So we get this. Next, take the one, if x belongs to clearly 1 to infinite, then sin inverse x is sin inverse of 2x by 1 plus x square value we want. Already we know that in properties of inverse trigonometric functions, already we discussed, that is 2 tan inverse x, if x belongs to 1 to infinity, to open interval, so 2 tan inverse x is equals, 2 tan inverse x equals, already discussed, that is pi minus sin inverse of 2x by 1 plus x square. Already we have a formula, that is 2 tan inverse x equals to pi minus. Already we discussed in concept previous, that is 2 tan inverse x equals to pi minus sin inverse of 2x by 1 plus x square. We want sin inverse of 2x by 1 plus x square. If you transpose this term, minus term, from LHS to RHS to LHS, it will become plus 1b. So we get here sin inverse of 2x by 1 plus x square is equal. If you transpose this term, we get pi minus 2 tan inverse x. Pi minus 2 tan inverse x. Pi minus 2 tan inverse x is the answer. Next one. The value of x satisfies the equation. The value of x satisfies the equation. Tan square x equals tan inverse of tan 3. Tan inverse of tan 3 is solution. Already we know that tan inverse of tan theta is equals to clearly theta. Tan inverse of tan theta is equals to clearly how much? Theta. So we have tan square x is equals to tan inverse of tan 3 means we get 3. Tan inverse of tan 3, tan inverse of tan theta tan inverse of tan theta is nothing but how much? Theta. But tan square here, tan inverse of tan theta is equal to theta. But here the value is theta clearly lie between theta is lie between clearly minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. But here theta is not there. Theta is not there. Here the value is 3. So it is clearly we have a formula that is tan inverse of tan theta is equal to 3. Tan inverse of tan theta. Tan inverse of tan theta is equal to theta. Tan inverse of tan theta equals to theta. But here in the place of theta, here we value 3. 3 clearly minus pi by 2 lie between plus pi by 2. So tan square x is equal to we get 3. Tan square x is equal to how much? 3. So this can be written as tan x whole square is equal to 3. Tan square x can be written as tan x whole square is equal to 3. So if you transpose square from LHS to RHS, it will become square root. So tan x is equal to plus or minus square root of 3. Plus or minus square root of 3. So here tan x is equal to plus or minus square root of 3. That means already we know that is root 3 means we get, if you take root 3, tan x equals to root 3 means tan x is equals to tan pi by tan 60 value square root of 3. Tan 60 value square root of 3. So we get tan pi by 3. Tan 60. So if you compare x is equals to how much? Compare LHS and RHS, x value pi by 3. X equals to how much? Pi by 3. Also we get minus square root of 3 means it is in lies between second quadrant or fourth quadrant. If you take 90 plus theta, so 90 plus pi by 3, that is pi by 2 plus pi by 3, we get minus 3. Minus of square root of 3. So x value is there will pi by 3. Next solution. If sin inverse 1 minus sin inverse of square root of 3 by x equals to pi by 6, and x is a root of the equation, x is a root of this equation, then the value of k, we want value of k. So the given equation is sin inverse of 1 minus sin inverse of square root of 3 by x value how much? Pi by 6. Already we know that sin inverse of 1 means is clearly pi by 1 can be written as right here. Sin inverse of 1 means 1 can be written as sin inverse of sin 1 can be written as sin pi by 2. Sin pi by 2. Sin 90 value 1. So we get how much? Pi by 2. Right in the place of sin inverse 1. So we get pi by 2. Pi by 2 minus, if you transpose pi by 6, we get pi by 6 is equal to, if you transpose this one from LHS to RHS, we get plus sin inverse of square root of 3 by x. Clearly, pi by 2 minus pi by 6. 6 is the LCM. 3 pi minus pi is equals to sin inverse of square root of 3 by x. 3 pi minus pi, clearly 2 pi by 6, 2 ones, 2 3s is equals to sin inverse of square root of 3 by x. If you transpose sin pi by 3 is equals to square root of 3 by x. Sin pi by 3. Sin pi by 3 means sin 60 value clearly square root of 3 by 2. Square root of 3 by 2 is equal to square root of 3 by x. We want x value. So squaring on both sides we get 3 by 4 is equal to, squaring on both sides we get 3 by 4 is equal to 3 by x. 3 by 4 is equal to 3 by x. 3 get cancelled, x value clearly 4. X value how much? 4. So x is the root of given equation. X is a root of the equation which is x square plus kx minus 1 is equal to. If you substitute x value here, 4 square 16 plus 4k minus 1 is equal to 0. So 4k 16 minus 1 we get plus 4 is equal to 0. 4k is equal to minus 4. K is equal to minus 1. So the value of the k is clearly minus 1. If tan inverse x plus tan inverse y plus tan inverse z is equal to pi by 2, then what is the value of? Find the value. Already we know that tan inverse x plus tan inverse y is equals to tan inverse of x plus y by 1 minus xy. Tan inverse x plus tan inverse y is equals to tan inverse of x plus y by 1 minus xy. Substitute here. We get tan inverse of x plus y by 1 minus xy plus tan inverse z is equals to we have pi by. Again within the form of tan inverse total this is x, this is y. Again within the form of tan inverse x plus tan inverse y. This is equals to clearly tan inverse of x plus y by x plus y by 1 minus xy. X plus y by 1 minus xy. 1 minus x value x plus y by 1 minus xy into y plus is equals to pi by. So if you transpose here we get x plus y plus what is the LCM here? Y into 1 minus xy by 1 minus xy is the LCM. Again by 1 minus xy minus y into x plus y by again here 1 minus xy is the LCM is equals to tan pi by 2 is equals to how much? Tan pi by 2. How do we know that? Tan pi by 2 value. Tan pi by 2 value does not exist. So 1 minus xy get cancelled. We get here x plus y plus y minus xy square by we get 1 minus xy here 1 minus xy this is the answer 1 minus xy. So 1 minus xy minus x into y xy minus x into z xz is equals to tan 90 value does not exist means if you take 1 by 0 value does not exist. If you do cross multiplication we get this into this 0 this into 1 minus xy minus this is xy minus xy. So clearly this is z, sorry, this is z. So we get here z. This is z is this value is x, this value is y. So this is z. So we get z. So here we get z in x, xz minus zy minus yz. So minus xy minus xz minus yz is equals to where is 0. If you transpose this quantity, so 1 is equals to xy plus yz plus zx. Therefore, xy plus yz plus zx is equals to xy plus yz plus zx equals to how much? 1. So, how do we remember? Tan inverse x plus tan inverse y equals tan inverse of x plus y by 1 minus xy. So, this is x plus y. So, we get this. Again, if you take this is value x, this value y, we get tan inverse x plus y by 1 minus xy. Y value there is 0. So, if you do this is transpose this, we get tan by 2. So, this is the answer. Next problem. Tan of pi by 4 plus 1 by 2 into cos inverse of a by b plus tan of pi by 4 minus 1 by 2 cos inverse of a by b value. Let here solution. Let cos inverse of a by b is equals to x. Cos inverse of a by b is equals to x. We get here tan pi by 4 plus this value is x or take any theta, anything we want, that is right here x by 2, right? Cos inverse a by b value x. If you take this, we get tan pi by 4 plus x by 2 plus here we get tan pi by 4 minus cos inverse of a by b x. So we get here x by 2. How do we know that? Tan a plus b formula. Tan a plus b is equals to tan a plus tan b value. Tan a means tan pi by 4 plus tan b, that is tan x by 2, by 1 minus tan a into tan b plus again tan a minus b. Tan a minus b is equals to tan a minus tan b by tan a minus tan b by 1 plus tan a into tan b. 1 plus tan a into tan b. So tan pi by 4. Tan pi by 4 means tan 45 value. Here 1 plus tan x by 2 by. Here also tan pi by 4 value 1. So 1 minus we get tan x by 2 plus here we get tan pi by 4 value tan 45 1. So 1 minus tan x by 2 by 1 plus tan x by 2. Here clearly what is the LCM here? LCM is clearly 1 minus tan x by 2 into 1 minus tan x by 2 into 1 plus tan x by 2 is LCM. So if you do cross multiplication, 1 plus tan x by 2 into 1 plus tan x by 2, we get 1 plus tan x by 2 whole square plus here we get 1 minus tan x by 2 whole square. So that is equal to a plus b whole square formula, that is a square plus b square plus 2ab. So a square means we get 1 plus b square means we get tan square x by 2 plus 2ab, that is 2 tan x by 2 plus a minus b whole square formula, that is a square plus b square minus 2ab. So we get here a square plus b square means tan square x by 2 minus 2ab means minus tan x by 2. But here it is in the form of a minus b into a plus b. A minus b into a plus b clearly a square minus b square. We get 1 minus tan square x by 2. 1 minus tan square x by 2. That is equal to 1 plus 1 clearly 2. 2 tan x by 2, 2 tan x by 2 get cancelled. Tan square x by 2, tan square x by 2 plus 2 tan square x by 2. But here 1 minus tan square x by 2. So if you take common 2, we get 2 times, if you take 2 as common, 1 plus tan square x by 2 by 1 minus tan square x by 2. If you write here like this 2 by, we get here, this can be written as like this 1 minus tan square x by 2 by 1 plus tan square x by 2. So 1 minus tan square x by 2 by 1 plus tan square, its reciprocal is clearly this is 1. Its reciprocal is this one. Our convenience, this can be written as 1 minus tan square x by 2 by 1 plus tan square x by 2. So 1 minus tan square x by 2 by 1 plus tan square x by 2, we have a formula that is cos 2a. So that is cos 2 theta. So that is equal to 2 by cos 2a. That means 2x by 2. 2 get cancelled. That is equal to 2 by cos x. 2 by cos x. So cos inverse of a by b is equal to x. That is equal to a by b is equal to we get cos x. A by b is equal to we get cos x. So cos x by a by b. So right here 2 by a by b, we get 2b by b. So answer is clearly 2b by a is the answer. If tan inverse x plus 1 by x minus 1 plus tan inverse of x minus 1 by x is equal to 5 plus tan inverse of minus 7, then the value of x. Already we know that tan inverse x plus tan inverse y is equal to, that means if x is greater than 0, is clearly 5 plus tan inverse of x plus y by 1 minus x by. If x is greater than 0, y is greater than 0, xy is greater than 1. If x is greater than 0, y is greater than 0, if xy is greater than 1, then tan inverse x plus tan inverse y is equal to 5 plus tan inverse of x plus y by x plus y by 1 minus xy. 1 plus x plus y by 5 plus tan inverse of x plus y by 1 minus xy. So it is in the form of tan inverse x plus tan inverse y. Value is clearly 5 plus tan inverse of x value x plus 1 by x minus 1 plus y value x minus 1 by x by 1 minus xy, that is x plus 1 by x minus 1 into x minus 1 by x is equal to, value is given 5 plus tan inverse of minus 7. 5 plus tan inverse of minus 7. So 5 and 5 get cancelled. So we get here, compare LHS and RHS, we get here x into x plus 1 plus x minus 1 whole square by x into x minus 1 by x into x minus 1 minus x plus 1 into x minus 1 by x into x minus 1. This is LCM is equals to, here else tan inverse of x is equals to tan inverse of minus 7. If you compare LHS and RHS, we get minus 7. So tan inverse of x is equals to minus 7. We get this is tan inverse of x equals to tan inverse of minus 7. LHS and RHS compared which we get this is. Clearly, x into x minus 1, x into x minus 1 we get cancel. So next, x into x square plus x minus 1 whole square means we get x square plus 1 minus 2x by x into x square minus x minus a plus b into a minus b, a square minus b square, we get minus x square plus 1 is equals to minus 7. If you transpose this, we get here x square 2x square plus x minus 2x. Clearly, minus x plus 1 is equals to minus x square get cancelled, minus 7 into minus x plus 1 to be. So 2x square minus x plus 1 is equals to minus of minus plus 7x minus 7b. So if you transpose here 2x square minus x plus 1 minus 7x plus 7 is equals to 0. Clearly 2x square minus 8x minus x minus 7x minus 8x 7 plus 1 8 is equals to 0. If you take 2 as common, we get x square minus 4x plus 4 is equals to 0. So here the LCM is this is quadratic equation. If you find the roots by splitting method, a square minus 2ab 2 into 2x 2 into x into 2 plus 2 square. It is the form of a square minus 2ab plus b square. This square clearly a minus b whole square. If you take x square minus this is can be written as minus 2x plus 4 is equals to 0. That means if you take x is common, x minus 2 minus 2 is common, x minus 2 is equal to 0. That means x minus 2 into x minus 2 is equals to 0. If you take x minus 2 common. So x minus 2 is equals to 0, x is equals to 2. Here also x minus 2 is equals to 0, x is equals to 2. So the value of x is clearly 2. Value of x is how much? 2 is the so if sin inverse of x minus x square by 2 plus x cube by 4 plus and so on plus cos inverse of this one is equals to 5 by 2. Clearly mod x is relatively interior and square root of 2. Then the value of x will 1. So clearly x minus solution is x minus x square by 2 plus x cube by 4 plus and so on. Clearly this is minus. It is GP. It is in a GP. It is a GP. A is equals to x and common ratio R is equals to minus x square by 2 by x, that is minus x square by 2 into 1 by x get cancelled. We get minus x by 2. So S infinity is equals to, already we know that formula. S infinity is equals to A by 1 minus R. Clearly A value x by 1 minus R value 1 plus x by 2 plus this. So also 1 x square minus x power 4 by 2 plus x power 6 by 4 plus minus and so on. It is also in GP. So here it is a GP. So clearly A is equals, first term A is equals to x square and common ratio R is equals to minus x power 4 by 2 into 1 by x square. X square and this 2 get cancelled. We get minus x square by 2. So common ratio is equals to minus x square by 2. We know that S infinity is equals to A by 1 minus R. A value clearly x square by R is 1 plus x square by 2. If you substitute here, we get that is the sin inverse of we get x by or here if you do LCM x by 2 plus x by 2, that is equals to 2x by 2 plus x, 2x by 2 plus x. So we get here 2x by 2 plus x plus cos inverse of here, observe here also we get, if you do LCM, 2x square by 2 plus x square, we get 2x square by 2 plus x square. So we get here 2x square by 2x square by 2 plus x square. is equal to how much? Pi by 2. But we know that sin inverse of x plus sin inverse x plus sin inverse y is equal to sin inverse x plus sin inverse x plus cos inverse x is equal to pi by 2. Sin inverse x plus cos inverse x is equal to pi by 2. Sin inverse x plus cos inverse x is equal to pi by 2. That means here both are equal. So these both are equal. So from this one 2x by 2 plus x value is equal to 2x square by 2 plus x square. 2x by 2 plus x equals to 2x square by 2 plus x square. Clearly, it is 2x by 2 plus x. 2x square by 2 plus x square. It will satisfy only. It will satisfy x value 9 is and root 2. It will satisfy only if x is equals to 1. It will satisfy. Observe here 2 into 1, 2 by 2 plus 1, 3 is equals to 2 1 square is 1. 2 only, 2 plus 1 we get 3. So 2 by 3 equals 2 by 3. So it will satisfy by x is equals to 1. Or if you do cross multiplication, we get x equals to 1. So 0 also it will satisfy, but value of x is greater than 0, less than root 2 by 2. So only one solution, that is x equals 1, it will satisfy. So x value is how much? 1. Next, other here, solution. Sin inverse x plus sin inverse y plus sin inverse z equals 3 pi by 2. If it is possible only, sin inverse x plus sin inverse y plus sin inverse z equals 3 by 2. Already we know that domain of sin inverse x equals to domain of the sin inverse x is clearly range of the sin inverse x minus pi by 2 to plus pi by 2. Minus pi by 2 to plus pi by 2. If you take the maximum value, we get minus pi by 2 comma plus pi by 2. That is sin inverse x is equals to sin inverse y is equals to sin inverse z is equals to value 3 pi by 2. So pi by 2 plus pi by 2 plus pi by 2 is nothing but 3 pi by 2. So sin inverse x equals sin inverse y plus sin inverse z equals pi by 2 means clearly x is equals to y is equals z is equals to 1. X value sin inverse x equals sin pi by 2. Sin 90 value also x y value x value y value z value equals to 1. If you substitute here, we get 1 x power 1 not 1. That means 1 power 1 not 1 is 1 only. 1 y power 1 not 1 only. Into x power 2 not 2 1 only. 1 power 2 not 2 1 and y power 2 not 2 again 1 by x power 3 not 3 again 1 plus y power 2 not 3 again 1 into y power 4 not 4 1 plus again y power 4 not 4 1. That is equals to 1 plus 1 2 2 plus 1, that is 1 plus 1 how much? 2 2 into 2 4 y here also 4. So that is equals to we get sigma 1 is nothing but here we want 1 plus x plus y plus z. Sigma 1 means we have sigma, this one means x plus y plus z. X plus y plus z we want. So 1 plus 1 plus 1 we get 3. X plus y plus x plus y again y plus z again z plus x. So 1 plus 1 plus 1 we get how much? 3. So answer is 3. If you this is up to x y z 3 terms. So this is one term. If you extend x plus y after that x plus y plus z after that z plus x. So this value 1 plus 1 plus 1 we get how much? 3 1. So 1 plus 1 plus 1 is equal to how much? 3. So this is value is 1. Again if you extend this we get after that y z term z x term. So this is 1, next term 1 we get 1 plus 1 plus 1 how much? 3. So we get 1 plus 1 plus 1 3 is the answer. Inverse x plus next one. If sin inverse x plus sin inverse of 2x is equals to pi by 3, then x equals to r. If you transpose this one we get right first here sin inverse x plus sin inverse 2x is equals to sin inverse x plus sin inverse of 2x is equals to pi by 3. Pi by 3 means clearly sin pi by 3. 180 by 3 means sin 60. So this can be written as sin inverse of sin 60 value square root of 3 by 2. So pi by 3 can be written as sin inverse of square root of 3 by 2. Sin 60 value how much? root 3 by 2. So pi by 3 is nothing but 60. 60 can be written as sin inverse of root 3 by 2. Sin inverse of root 3 by 2. If you transpose sin inverse x, here we get sin inverse 2x is equal to sin inverse square root of 3 by 2 minus sin inverse x. Already we know that sin inverse x minus sin inverse y. Sin inverse x minus sin inverse y is equal to. So already we know that sin inverse 2x is equal to. Alright, sin inverse x minus sin inverse y is equal to sin inverse of x into square root of 1 minus y square minus y into square root of 1 minus x square is the formula. So if you substitute here, sin inverse of 2x is equal, sin inverse of 2x is equal to sin inverse of, this is x, this is y, x into means 3 by 2 into square root of 3 by 2 into square root of 1 minus y square means square root of 1 minus x square we get minus y into y value here x into square root of 1 minus x square means 1 minus x means here square root of 3 by 2 we get 3 by 4. X square means root square get cancelled 3 by 4 we get, that is. So if you compare LHS in RHS, 2x is equal to clearly square root of 3 by 2 into square root of 1 minus x square minus x into square root of 4 minus 3. 4 minus 3, 1. 1 by 4. 4 minus 3, how much? 4 minus 3, 1 only. 1 by square root of 1 by 4 means we get 1 by 2. Nothing but x square. This is. Here, square root of 3 by 2. This is. 2x is equal to. So, we want x value. So, here we clearly LCM is 2x is equal to square root of 3 into 1 minus x square minus x by 2. So, to do 4x. 4x is equal to 4x is equal to. And also transpose this x, we get plus x is equal to square root of 3 into square root of 1 minus x square we get. Squaring on both sides, 4x plus 5x, 5x, we get 25x square is equal to 4x plus x, how much 5x? 5x whole square means we get 25x square. Root 3 means 3 into 1 minus x square. So, 25x square is equal to 25x square is equal to 3 minus 3x square. If you transpose 3x square, we get here 28x square is equal to 3. X square is equal to 3 by 28. X square is equal to 3 by 20. So, x is equal to plus or minus square root of 3 by 28. So, this can be written as square root of 3 by square root of 28 means 4 into 7. 4 into 7. So, we get here square root of 3 by root 4 means we get 2. So, root 3 by 2 root 7. X value how much? Square root of 3 by 2 into square root of 7 is the value of x. Cos inverse x is equal to cos inverse 2x square minus 1 satisfied by. That means we want the domain of this function. Already we know that the cos inverse x domain of cos inverse x is clearly minus 1 to plus 1. Minus 1 to plus 1. So 2x square minus 1. 2x square minus 1 value, we want x value. 2x square minus 1 value, clearly lie between minus 1 is less than or equal to x square minus 1 is less than or equal to 1. So we want x value. If you add both sides, we get minus 1 plus 1 is less than or equal to 2x square minus 1 plus 1 is less than or equal to 1 plus 1. Minus 1 plus 1 value is 0 is less than or equal to 2x square. Minus 1 plus 1 get cancelled, less than or equal to 2. So we want x value. So both sides divided by 2. We get here 0 by 2. 0 by 2 is less than or equal to x square by 2x square by 2 means we get 2 on x square only. 2 by 2 means we get 1. So 0 is less than or equal to x square is less than or equal to 1. So we want x value. If you apply both sides root, we get 0 is less than or equal to x is less than or equal to 1. So the domain of this function is clearly 0 is less than or equal to x is less than or equal to 1. 0 is less than or equal to x is less than or equal to 1 is the domain of the function. Next, 8th one, cos of tan inverse into sin of cot inverse x value we want. So let us assume that here cot inverse x value theta. So cot theta is equals to we get x. If cot inverse theta is equals to cot inverse x is equals to theta, cot inverse x is equals to theta, then cot theta is equals to x. Already we know that cot theta is equals to x. If you take right angle triangle, this is, if you take theta here, cot theta means merely adjacent side to theta by opposite side to theta. Adjacent side to theta is 1, opposite side to theta is, adjacent side to theta is x, opposite side to theta is 1. What is the value of this one? Is clearly square root of 1 plus x square. By using of Pythagoras theorem, we get square root of 1 plus x square. So cot theta is equals to x. What is the value of sin theta? Sin theta is equals to merely opposite by hypotenuse. We get 1 by square root of 1 plus x square. So theta is equals to we get sin inverse of 1 by 1 plus x square. So this is theta. What is x value theta? In the place of theta, we write cos of tan inverse into sin inverse 1 by 1 plus x square. Let us assume that this value is theta. So in the place of theta, we write sin inverse of 1 by 1 plus x square. Sin inverse x clearly x. So we get here cos of tan inverse, we get 1 by 1 plus x square. 1 by 1 plus x square. Sorry, this is square root of 1 by 1 plus x square. Square root of 1 by 1 plus x square. This is. So if you take here also right angle triangle, this is tan inverse x, this value is tan inverse 1 by square root of 1 plus x square is equals to theta. Tan theta is equals to 1 by square root of 1 plus x square. If you take theta here, clearly this is 1, this is square root of 1 plus x square. What is the value of hypotenuse is 1 plus x square plus 1. We get 2 plus x square. 2 plus x square also square root by using of Pythagoras theorem. A, B, C. That is AC square is equals to AB square plus BC square. That means AC square is equals to AB value 1 plus BC square means 1 plus x square. We get 2 plus x square. We want AC value. So AC value is square root of 2 plus x square. So we get in terms of we want cos. So cos theta is equals to cos of this value is theta. In the place of theta, we write this is cos theta we want. Cos theta is equals to merely adjacent side to theta by hypotenuse. That is square root of 1 plus x square by square root of 2 plus x square. Square root of 1 plus x square by square root of 2 plus x square. Square root of 1 plus x square by square root of 2 plus x square will be 2 plus x square. So this can be written as cos inverse of square root of 1 plus x square by 2 plus x square. We get this is cos inverse. We get cancel. So we get 1 plus x square by x square plus 1 by x square plus 1 by x square plus 2 whole to the power 1 by 2. Square root means we get whole power 1 by 2. This is the answer.